So my name is Chris, and today I'll be talking about using F#, so .NET language, and to use F# to produce JavaScript code that can be run in the browser, basically, or on the JavaScript ecosystem. I'm open source developer. I maintain a couple of popular in F# community projects. In some free time, I do also try to earn some money and do some F# consulting and things like that. In the past, I've used to be C# developer, JavaScript, TypeScript developer, but for the last couple of years, I've been doing mostly functional programming. Well, for the last 2 years, I've been doing 100% functional programming, mostly with F#, some Elixir, some Elm, things like that. And not to go too deep, but why F#? Oh, before we go, how many of you are .NET developers? How many of you are JavaScript developers? Perfect. How many of you have attended Isaac talk just before? Couple of you. Okay, so I will do a quick introduction to F# if you haven't ever seen the language. First of all, why F#? It's general purpose programming language, so we can do whatever we want with F#. It's running on .NET platform. It's compiling to same bytecode as the C#, so wherever C# is supported, you can use it also. Whatever supports C#, you can use it also with F#. So Azure, Cloud, all these things works perfectly fine with F#. Secondly, it's functional first language, so it focuses on the functional programming features. C# in recent years have gained a couple of functional programming features, but you can say that C# is object-oriented first language, and then it gains those functional programming features that if you want to use them, then you can use it, and it's getting more and more of those features. On the other hand, F# is kind of other way around, so it's functional programming first language, so it focuses more on functional programming approach, and then it has additional object-oriented features for the compatibility with the platform and with C#. It has really powerful type system. I will go, when I will show a syntax a bit, I will show what do I mean, but it has some additional guarantees that we cannot easily express in C#. We can easily do it with F#. It's really pragmatic language, so the community is focused on solving problems, not like a lot of the functional programming communities when people only talks about mathematics and monads and all this weird stuff that no one understands. F# community is super focused on just getting stuff done and building cool stuff. And community in general is great. It's probably at the moment for me, it's probably one of the most important factor why I'm still doing F# and haven't moved somewhere else. Community is amazing. Community helps to solve a lot of problems. Community builds great open source ecosystem of tooling and libraries that can be easily used to solve problems. Yes, and quickly going through syntax. This is basically assigning the value, binding the value to the symbol. What's important is that I don't specify any types in these 3 lines of code, but F# is statically typed language. So those types, the fact that value is integer, value2 is string, and list is the list of integers, is inferred by the compiler. So do I have? Yes, I have tooltips. So as you can see, it's integer. It's list of integers. So you have normal statically typed language, but you don't need to type those additional type information in the code. I've heard this great saying on Twitter that if from some of the, I think, Haskell guys or someone like that, that he's not surprised that people like dynamically typed languages like Ruby or whatever, Clojure, because if he knew only type system of Java and C# and that you need to type everything, he would also be a he would also use dynamically typed programming language, because it's just waste of time. Why not let machine compiler to do this stuff for us. Secondly, the type system. F# has a couple of additional features on top of normal C# classes and things, structs and things like that. First of all, it has models, it has records. In our case, model is the record. You can treat records as classes because they are basically compiled to the classes under the hood, but what's important is that they are immutable by default. They implement structural comparison, they implement hashing. So if you want to do a value type in C#, value type in understanding of domain-driven design, which is like not compared through references, but through values and things like through comparing the values of all fields and stuff like that. You need to write tons of lines of code, and you need to implement get hash code and things like that. Here, everything is done automatically by compiler. It's immutable by default. It has additional syntax that lets you change some value in the record, but produces new record, not mutating the record in place. So that's great. That saves a lot of typing. And second really important type is the discriminant union type. It basically lets you say that something can have multiple cases. So in our case, we have type shape, which can be either circle, rectangle, or something else. And typical way to do this in object-oriented language is to create some abstract class and create some additional classes that implements this abstract class. And it's getting also super messy. Here it's really easy to define such type. Here is how we create instance of those types, of this type. And as you can see, whoops, sorry. And as you can see, circle is of type shape, rectangle is of type shape, and something different is of type shape. So any of those values will be accepted by the function that wants us to pass type shape. We also have mechanism called pattern matching, which actually is added in the latest version of C#, I believe, or is planned to be added, which lets you, it's like switch case statement. Basically, you match on every possible case, and depending on which case is it, you perform some action, but we'll see this a bit later. Third important thing, higher order functions, anonymous functions, and pipe operators. So this fun N and arrow is the F# way of defining anonymous function. So in C# it's like N and big arrow, I believe, without fun, but that's obviously advantage of F#, but because it's language that has fun in itself, so you can have fun with it. Higher order functions is mechanism of passing functions as a values to the other functions. So list map is a function that as a parameter accepts other function. So that enables us to build like composable functions together. It's somehow similar to, probably in like object-oriented language, you would solve it by dependency injection or inversion of control, so passing the parameters to the class that changes behavior. Here we just passes the functions on the runtime. And the pipe operator is really similar to the pipe from the Linux operating system. So it takes value from the left and put it as a rightmost value for the next function. What's really nice about pipe operator is that it enables this nice workflows of transformations. So you have some input data, you do one transformation, you do another transformation, you do a third transformation, or whatever, how many those transformations you need. And every step produces, every step produces something that is accepted by the next step. So that's really, really, really nice feature. And the last important thing from this stock point of view is our computation expressions. So if you are C# developers, or maybe even played with new JavaScript versions which are not in standard, but there is this async await concept which enables us to do asynchronous code easily without caring too much about complex stuff. So this is similar. So this is async block. Code in this block is executed asynchronously, and let bank is somehow something like await. So basically, it waits for the result and moves forward. What's really nice about F# is that it's not built in. Well, async is built in, but it's not some special syntax. It's not some special syntactic sugar, like in case of C#, where async await are not extendable, or you cannot do anything like that without changing to the compiler. In case of F#, there is a more generic way of, it's implemented in the compiler in more generic way, so you can implement your own computation expressions. So for example, in case of JavaScript, we create promise computation expression which works with JavaScript promises, which are basically asynchronous code, but because we are living in JavaScript ecosystem, we want to follow their conventions and be compatible with their code. So we can create promise computation expressions which let us do let bank and await for the promise result, which supports normal promise implementation that's used in JavaScript ecosystem. There are a couple of those, but whatever. So that was quick introduction to F#. And now, why JavaScript? Because it runs everywhere. That's main reason. Let's not kid ourselves. If JavaScript was not the language running in the browser, it probably wouldn't be so popular because it's not the best language, at least in my point of view. It has really innovative and open community, which is, from my point of view, as open source developer, as someone who spends a lot of time working with community, it's really important, because .NET community in general often seems to be a bit conservative and they don't want to move forward. Great example for that is the way those two ecosystems approaches UI development, graphical UI development. So C# developers 15 years ago came up with MVVM, which is model view model, and for last 15 years everyone is doing basically the same, while JavaScript ecosystem moved from MVVM in 2012 with Knockout.js and things like that to right now basically doing functional programming style UIs with things like React Redux. So it's basically 5 years and the progress was amazing, and I'm really love the fact that JavaScript community is open to these innovations. And I know a lot of people are joking about, oh, what's the UI framework of the week? But yeah, that's the problem. On the other hand, advantage is huge because like we innovate and we move forward and we come up with new things, and I think that software developers shouldn't only be focused on like writing their code and maintaining, but also let's try to make lives of other developers better. It also have really decent virtual machine. In recent years, it's been optimized heavily because basically everyone wants to run as much code in browser. Everyone wants to run also JavaScript in the server with Node.js, and really like lot of engineering effort is put into optimizing and making JavaScript VMs better. Probably more work than it's spent on both .NET and JVM VMs, which are kinda trying to be stable. Well, maybe JVM is trying to improve a bit, but especially .NET VM is trying to be super stable and don't try to do anything because they're afraid to break things. So I've mentioned community, I've mentioned VM, I've mentioned ecosystem, I've mentioned the fact that you can run everywhere. In YJS, I haven't mentioned language. Language is, at least in my opinion, that's like controversial topic, and I know that a lot of people likes JavaScript, but for me, JavaScript is not the best programming language. So basically, there are a lot of projects trying to compile other language to JavaScript and treat JavaScript just as assembly language or just as runtime, something like that. And yeah, there's quite a lot of those projects. TypeScript from Microsoft, which is basically a superset of JavaScript, adding some nice typing and some pretty powerful type system to the language. Flow is from Facebook, I believe. They are trying to solve same problems as TypeScript, but without changing the core of JavaScript, but using annotations to do typing. There are also different languages that tries to compile to JavaScript. So there's probably from the functional programming languages, the most oldest one is ClojureScript. Clojure has been supporting compiling to JavaScript since always, basically. Well, for a really long time, before even most of other projects were created. Elm is getting a lot of traction. It's ML language, similar to F#, bit more limited. I wouldn't call Elm general purpose language. It's language which is designed to solve one problem and solves this problem really well, and the problem is building single page applications. PureScript, which is more Haskell-ish language. There are also other options like Scala.js. I believe later today we will have talk about Scala and Scala.js, so you can go there and compare what I'm talking about in context of F# with what Scala guys are doing if you are focused more on JVM. OCaml to JVM, and basically nowadays every language tries to provide this alternative backend and be compiled to JavaScript, because everyone sees that JavaScript is getting so much traction and so much popularity that you just cannot avoid that. I think a couple of weeks ago there was like huge hype about some C# to JavaScript compilation thing called Bridge or something. I don't really know anything about that, but if you want to use object-oriented language on JavaScript ecosystem, use TypeScript. It has way better type system than C#. Interesting thing in all those cases is Babel, and Babel is JavaScript to JavaScript compiler. So that was also on Twitter. So when they've announced it, they've said, "Oh, you think that JavaScript is only interpreted language and you need interpreter to run it?" Hell no, we've solved that. We created JavaScript to JavaScript compiler. What's cool about Babel, and it's widely popular in JavaScript community, is that it enables using the new experimental features of JavaScript, which are not yet implemented by all the browsers or are not yet in the standard. So things like async await, I believe, or things like, yeah, there are a lot of those features. Alternative import syntax, things like that. You can use, those things are planned, those things are designed, maybe even accepted by the committee of the JavaScript, but are not yet implemented by all the browsers. So using Babel lets you use those new features, new fancy features, and compile to old plain JavaScript standard that's supported ECMAScript 5, I believe, which is supported by all browsers nowadays. What's important, it also accepts AST as an input, not only just JavaScript files, but you can create abstract syntax tree. There is some JSON way of serializing this abstract syntax tree, and that's important for us. And now we come up to Fable. So Fable is F# to JavaScript compiler. It's open source project created by F# community. It's using Babel as a middle step of the compilation process. So as I've mentioned, Babel accepts AST, and Fable, instead of the whole process with compilers transpilers looks usually like you have language service. This language services produces abstract syntax tree for the language language X, and then from this abstract syntax tree you try to output JavaScript code. What Fable does is it doesn't try to output JavaScript code directly. It transforms abstract syntax tree of F# into abstract syntax tree that Babel accepts, which is way easier. Like, it's just mapping between two types. So transforming abstract syntax trees is still a complex problem, but it's way easier. And then Babel, which is widely used, have a lot of support, and is JavaScript community ensures its good quality, is responsible for producing JavaScript. This is really important because it, unlike some other compilers to JavaScript, it enables Fable to do really deep integration with existing JavaScript ecosystem. Because Babel is deeply integrated with existing JavaScript ecosystem, so using things like Webpack, using things like rollup and plugin and minifiers, uglifiers, Babel.js plugins, it all works out of the box without any problem with Fable. Another important thing is that Babel, since it's so widely used, they really care about quality of the JavaScript code they produce. So that's like Fable gets that for free. Babel produces source maps. Source maps is the mapping that enables existing JavaScript tooling like Chrome developer tools or debugger in the Visual Studio Code to map between those compiled JavaScript files and your original F# file in our case. So you can do F# debugging inside of Google Chrome without any problems, and that just works. And I will show that in a demo in a few moments. Yes, and now let's move to demo one. Hopefully it will work. Demo gods are really dangerous. So yeah, let me just start compilation process. What's important, another important fact about Fable is that because of this deep integration with tooling, it also tries to integrate with TypeScript tooling, and TypeScript has this feature called definition files. Definition files in the TypeScript usually most of the JavaScript libraries in the world were not written in TypeScript or in any other languages. They were written in JavaScript, and TypeScript definition files is you basically create the file which includes type information about existing JavaScript library, so you can easily use it from TypeScript. What's nice about Fable is that we can generate Fable bindings. So Fable has its own syntax using like its normal F# plain file with the types definitions, but you can, instead of writing it manually, you can take existing definition type, and there is like whole huge repository called definitely typed with thousands of existing definition types for many popular JavaScript languages. So you take such file and you output the F# file, which provides typed bindings. So you have this typed access to the JavaScript dynamic ecosystem, which is super cool. Has it compiled? Yes. So we have this simple application that it's really fancy. My graphical skills are amazing, and this is like animation, which I should get some award for that. Anyway, that's just normal JavaScript HTML5 canvas, and as you can see here on the right side in the code, we have typed access to canvas. We have typed access to its properties. We can set these properties, and then we have some type F# record that represents the particles and its position and how it will change its position. I won't go too deep into details of this code. It will be public online, so if you want to play with that. later, then feel free. There's a couple of things I would like to show about that. First of all is I've mentioned that you can debug this thing. And you can open Google Chrome developer tools. You can open appfs file. And then let's go to the update function and let's put breakpoint. Yeah, and it stopped. We have normal debugger informations we know from debugging normal JavaScript code in the browser. So that's like amazing. Let's continue. Second cool thing is that usually Fable projects uses Webpack under the hood or something like that, and Webpack is really powerful tool. If you don't know, Webpack is a tool in JavaScript ecosystem that's responsible of bundling all your files together and putting them into one file and do some magic, because you don't want to put online hundreds of JavaScript files. What's really cool about that Webpack has this feature called hot reload, which automatically detects the changes in a file and automatically reloads the web page. So here let's change something in update particle function. Let's save that. Here in the bottom, as you can see, there is some parsing, some compilation. Webpack compiled successfully, and left side automatically refreshed itself. I haven't had to press F5. I haven't had to do anything. It's all automatically automagic. That's great. That's the development workflow that standard C# developers or JVM developers doing some UI applications are not used to that. And it's really changing the way you work with the graphical UIs. Another cool feature is that, as I've mentioned, integration, and integration again. Let's say that you have existing TypeScript application and you want to slowly move to the Fable because you like Fable. You can use your existing TypeScript code, import it into Fable, and with the power of Webpack, everything will be put together and just work. So here I have the TypeScript file. It defines basically same type, so this particle interface, and the update function. And instead of using my F# update function, I will right now just import TypeScript function from TypeScript file. I can save my F# file. This will recompile again. Yeah, it restarted, but just to show you that it do anything. Let's do change in TypeScript file, save the file. Voila! So we have an application that's using both F# and TypeScript at the same time, compiling to JavaScript, automatically refreshing the browser. For me, it's like magic. And I'm always really surprised that it works. No, it works really well in practice. Let's go back to the talk. How much time do I have? Yeah. Perfect. The second important thing I want to talk about is this thing called Elm Architecture. It's basically, the name is a bit silly. It's model view. Actually, it should be called model view update pattern. But since Elm has become this super popular thing nowadays, everyone is calling this, and was first, and as a language is designed to use this pattern. So that's why we call it Elm Architecture or Elmish architecture. The important things about Elm Architecture is, first of all, you have unidirectional data flow. So you don't mutate data, you don't have two-way bindings, you have only one-way bindings and then events. I will show everything in a demo in a minute. It works really well with functional programming because all your data is in MView model view update pattern is immutable. So model part is actually two types. One type is the type that represents model, which is like data of your application. Second type is the type that represents actions that can happen in your applications. So that's, in our case, it will be F# discriminated union, because as I've shown, discriminated unions are a great way to model stuff that can have many cases, and we can have many different events in our application. View is simple function that takes existing model and produces HTML. And we don't really care what happens, but it just needs to produce HTML, and it needs to add event handlers. So on button click, we will dispatch new message to the system. And update is a function that takes old state, the message incoming, and based on those two things produces new state. So it's also a pure function. You don't mutate the model, you produce a new instance of the model. And basically what happens is that you click the button on your form, the event is dispatched, let's say counter incremented or something like that. This message is sent to update function together with existing state, with current state. We produces new state, and when new state is produced, we send this new state to view function, which produces HTML. This sounds probably the first thing you notice is, oh, that sounds badly because we need to probably re-render whole view or something like that. Fortunately, Facebook has brilliant engineers, and they've come up with this framework called React. React is using concept of virtual DOM to make sure that in case of such updates, you change only those part of the view that has actually changed. You don't re-render whole view. You don't re-render parts that were not changed. You re-render only this part of the view, this subcomponent of the view that has changed. And yes, even though we call it Elm Architecture, it's used also in plain JavaScript. React Redux is super complicated way of doing that. Vue.js is using basically the same concept, and it's way simpler than Redux. If you have some fancy reactive extension-based observable UIs, then you basically use the same thing. And now I believe, yeah, it's demo 2. Let's go. This is, yeah, let me start compilation again. So this is really simple hello world level application that displays counter, and you have two buttons that increment and decrements the state, and you have third button that can reset to the initial state of the application. So as I've mentioned, two types, model and messages that can happen. So model is just plain int. We don't have anything complex in that, but this model can usually is F# record, so it can have many fields, many values, store many values. And we have message type that are just three messages that can happen. Usually messages can carry some data. In our case, if that would be like add instead of increment, it could carry integer saying how much we've added or things like that. Okay, so that's the web page, and you can decrement counter, you can increment counter, and you can reset. Let's go to the state. So that's update function. As I've mentioned, it takes message, it takes existing model, it outputs new model. This is the construct called pattern matching I've mentioned before. So you pass to it an, in this case, instance of discriminated union, which is message. And now, depending on what type of or what case of the message it is, we perform different actions. So if it's increment message, we produces new model, we just add 1. Or subtract 1 or set model to 0. And the view Vue, in our case, is using nice F# DSL. It's really similar to HTML, so you should be able to understand that. What's important is that our view function gets model, gets additional dispatch function, which is what we use to send message from the what happens. We invoke this function when user clicks button, basically. And here it is. So, for example, on click, we just send some action to the dispatch function. That's nothing too complex. What's really interesting is, again, integration with existing ecosystem. So this is using React under the hood. This is actually not compiling directly to HTML, but to JavaScript React-based code. And then React is responsible for producing HTML and doing its magic, because we assume that we have our own problems to solve, and if someone else is solving the problem of rendering HTML and it's doing it super well, then they should do that. So we also have integration with existing tooling that supports React. So for Google Chrome, there are two extensions. One is React Developer Tools. Second one is Redux Developer Tools. React Developer Tools basically enables you to. It's somehow similar to default Elements view, but instead it's using Virtual DOM, React Virtual DOM, so you can see how React understands our view and see properties that are set here on the right-hand side. And you can click into that. That's really useful tool for, in general, doing React, but as a Fable, we are integrating with that. The second thing I think I will need to is, oh my god, that's small, sorry for that. Can I make it bigger? Yeah, that's too big. So Redux is also similar to Elm Architecture, based on the concept of invoking some actions and mutating the states. Well, not really mutating, but producing new state. So there is this tool called Redux Developer Tools. It's using, yeah, we can do some actions. As you can see here on the list, there are new actions are showing, and we can check what has happened here, how the state has changed. We can check what was the, like in JavaScript, in JSON view, what was the action. We can also see how the actions was dispatched through different dispatchers. The third, I'm running out of time, but the third thing I want to show you is really cool feature of React in together with Webpack is this thing called hot module replacement, which basically enables you to replace code on the runtime without replace JavaScript code in the runtime without refreshing your web page. As you've seen in previous example, everything was happening automatically, but we've refreshed the web page. So the old state was lost and the animation started from the beginning. Here, instead of the refreshing the web page, right now we have counter at -8. Let's change something. For example, let's change that our increment handler adds 10 instead of 1. So we save file. We wait as for the compilation. Compilation is successfully. Now we press +1, and it added 10 without refreshing the web page, without changing and losing old state. We just replace the stuff on the runtime, and now we have different behavior. So that's also, it changes a way you build UIs, because it enables this fast feedback loop, which is super important for building any software, and especially graphical UI software. Yes, and let's go back to the mobile development. Since you can use Fable with React, it's obviously you can use it also with React Native and target iOS and Android devices. You can also use something called Fuse. It's like some startup from San Francisco trying to solve cross-platform targeting of mobile devices, which is really nice. It's, again, integration with all tooling. So you are integrated with React Native debugger, so you can debug your F# code running on the Android emulator inside of Visual Studio Code, for example. Other things you can do with Fable. So you can do server applications with Node.js, for example, use Express.js to create the web server. You can use desktop UI applications with Electron. You can use Webtask.io or Azure Functions with Node.js to do serverless applications with F# compiled to JavaScript. You can target virtual reality machines with React VR. You can do data visualizations with D3. You can do games with WebGL and libraries like Pixie.js. So basically, whatever you can do with JavaScript, wherever it is, in browser, in desktop, in the server, in the cloud, you can do it with Fable. And yeah, that would be it. Small summary. So better language than JavaScript and integration with existing JavaScript tooling and existing JavaScript projects. That are most important things to me. And I know this talk was a bit rushed, but I hope you at least will go and play with Fable. And thank you for attention. Any questions? Do we have any questions? If not, I'm around today, tomorrow, so feel free to chat with me, and thank you again.